Welcome to the geology tour of the Salt Lake Valley. For today's tour, we're going to go from oldest to youngest, and so we will actually start and end in the same spot. So we're at the mouth of Little Cottonwood Canyon, where we have both the oldest and youngest rocks in the valley.
So from Little Cottonwood Canyon, we'll head north to Big Cottonwood Canyon and Mount Olympus, and then Mill Creek Canyon, and Grandeur Peak, and Parley's Canyon, and then a little bit farther north as we get to younger rocks, and then we'll end up circling back to Little Cottonwood Canyon, where the youngest rocks in the valley are.
So the oldest rocks in the valley are right here. This is the Little Willow Formation, and it is a quartzite. It's a highly metamorphic rock, meaning it got changed a lot by heat and pressure, especially as the youngest rock pushed its way up. So this rock is 1.7 billion years old as it currently sits, and probably originated about 3.6 billion years ago as ocean bottom sediments. They formed a rock, and then that rock in the last 15 million years was pushed up and exposed here to make the Little Willow Formation where we see it. So that is the oldest rock in the valley. Behind me is Mount Olympus. It is part of the Big Cottonwood Formation, which is a 16,000 foot thick layer of quartzite and shale that formed about 900 million years ago. And it formed when this spot was near the equator, so it was formed in a tropical to subtropical environment at the edge of an open sea. This rock behind me is the 700 million year old Mutual Formation. It is some shales that were formed at the bottom of an ancient sea, and it's purple in color due to the dissolved iron oxides in it. And we are a couple miles up Big Cottonwood Canyon.
Starting 550 million years ago, we get some of the first artist renderings of what Utah looked like. It would have had an ancient sea, and we'd get tintic quartzite that's going to form on a sand wedge on a tropical beach. It's going to form the beautiful north face of Mount Olympus. And as we keep going forward, we'll notice that that sea persists, and slowly we will see that parts of Nevada start to get added on to our continent as we move forward in time, and this ancient seaway continues to be part of Utah. As this seabed persists, it leads to the greatest limestone producing interval of geologic time in Utah and the Fitchville Formation, which can be found up at Hellgate in Little Cottonwood Canyon. The plate collisions of Pangea created basin and uplifts in Utah and Colorado called the Ancestral Rockies. And during this time, we get some Weber quartzite formed, which is formed from glaciation in the polar regions of Pangea. As seas return, we see limestone being deposited in the Park City Formation, which is followed actually with the Permian extinction, where 85% of sea species and 75% of land vertebrate animals disappeared. In the early Triassic, we get some continental sediments forming woodside shale, which actually doesn't show up very much in the canyons. And then we go back to seabed, where we get the Thames Formation, which forms a beautiful limestone ridge on Grandeur Peak.
We're at the mouth of Parley's Canyon, where I-80 heads east out of the valley, and we're looking east and we see the Ankara Formation right here. It's both the red and the light colored rock right there. It is a quartzite that formed on land with some shale in it, and there's some Garda grit, which is the purplish hue right about where they meet, and This formed when the Ancestral Rockies got lifted up and the sediments spread out, and so this is where the sediments got deposited. And Utah was located at actually 10 degrees north latitude when this happened, and it's been uplifted since. So this would have formed horizontally and has been tilted on its side. So other things we can see here. Over here we've got some nugget sandstone outcrops, and that formed during the Jurassic period, and it's related to Navajo sandstone down south, and it's part of a really big sea of wind-blown sand. Out here we'll find this outcrop, which is Twin Creek limestone that formed in a shallow sea that existed as part of a seaway from the Gulf of Mexico all the way up to Alaska. It's the youngest sedimentary rock. It contains some gypsum, which indicates it formed in a hot, arid landscape, and it formed over 144 million years ago.
As we enter into the Cretaceous period, lots of folding in the rock layers in the Wasatch happens, and if you kind of keep an eye on Colorado, you'll also notice that those ancestral Rockies, which were bigger than the Rockies we have today, actually start to wear away, and we know that a lot of those sediments ended up as coarse conglomerate rocks that are in Echo and Hennifer canyons, a little bit to the east of the Salt Lake Valley.
All right, so as we wrap up our tour, the youngest rock in the valley is actually back here. And this is the Little Cottonwood Formation, or Little Cottonwood Stock. It is an intrusive igneous rock that formed about 30 million years ago. It formed because the west coast of the US was a subduction zone, and it was a really shallow one. And so that subducting oceanic plate, as it went under, went really far before it melted. And this is one of the spots that magma was produced and came up towards the surface. Didn't make it towards the surface, that's why it's an intrusive rock. But about 30 million years ago it was formed, and it has since been uplifted and exposed. And part of that is that even more recently, we have the formation of this canyon, which is a glacially carved canyon from about 10,000 years ago. So it's U-shaped. You can kind of see how it's got a general U-shape. And it has formations in it like the Cirque at Snowbird and the Pfeiffer Horn just down canyon from that let us know that a massive glacier carved out this. And then also these white boulders back here on the hillside are transported there by the glacial action. So some of the youngest things to happen in the valley are right here as well. All right, so here we have some Little Cottonwood stock. It's a granite that was formed 30 million years ago. We're in Little Cottonwood Canyon now, and you can see it's a white and gray and black rock with larger crystals because it's an intrusive igneous rock, and it's composed of feldspar, quartz, and mica. And it's a beautiful rock and great for climbing on. Lots of climbers flock to this canyon from all over the world to climb here.
So 5 million years ago, Utah starts to look a lot more like what we know today. And then 10,000 years ago, Lake Bonneville happened, and this is the extent of Lake Bonneville at its largest, and it left behind the benches that we're familiar with and lots of big piles of conglomerate sediments.